Oh. So keep in mind, we only have an hour.
Oh, we do?
Yeah. We're sharing the slot with OpenPGP.
Oh, I didn't know that.
Yeah. So
Good.
We have 1 hour.
Okay.
And we're relatively close
Yep.
to having that full. So I think we're skipping the 0 RTT stuff unless there's something very compelling in it.
Okay, that's fine then, but it'll come up. But yeah. So.
Okay, shall we kick this off?
Yeah, let's get this rolling. Oh, person.
So good morning, all. This is Deprive. Hopefully, you expect to be in Deprive. Something that's worth noting is that we only actually have an hour slot because we're sharing this with OpenPGP, I believe. So let's get started. We've already done that. Oh, yes. Oliver says that he will be our Jabber scribe, and I think that Shane Kerr said he would do. You're still good for that?
Yep.
Thank you,
Thanks,
sir.
Shane. Sorry.
The blue sheets are
I
circulating.
started passing those around.
Great. This is the IETF note well. Please make sure that you note it well and understand what it means. It has important IPR stuff, and your lawyers presumably care. We're not going to interpret it. You need to do that yourself. Blue sheets. This is the agenda. The one we had posted online was somewhat incorrect. What, too small?
Should we read it for you?
That's okay. There we go. Yeah.
There we go. So hopefully you've all seen it and it's acceptable because we're not changing it now. Status up. Oh, should we do the presentations and come back to this?
I think the status should be pretty quick.
This is the status. You can read it yourself.
I think the one that's missing is there's two message flow drafts, which I gotten myself confused on, or two profiles. There's one profile draft that's been adopted, and there's one that's not been adopted. And I had confused myself when I was putting together the agenda, so I apologize for that, Sarah and Dan. And that's one that's actually missing at this moment. So.
And then obviously the other one we're still going to have to discuss is the draft IETF deprive eval document and how we actually move that forward on what we do with it. So presentations, I believe first up we have Dan. I haven't seen Dan in the audio. Oh, there's Dan, sir.
Yeah.
I didn't know if you wanted me to present this or not. But
yeah, this will be quick.
Stand in the pink box.
Yeah, in the box. Next slide. So we have one slide. Incorporated feedback into 05-06 we published Monday or Tuesday of this week, and then incorporates all the other feedback that we have received. And as far as we're concerned, we're ready for a working group last call. I like these nice short presentations.
We just wanted to see if there's any other comments about that. I think we'll probably move forward with that, with the working group last call, unless there's some protest either way.
Yeah, so I think there are still some outstanding comments, I believe, but I'm not 100% sure. Yep.
Sarah Dickinson, Synodon. I have made some comments in the past that I think the handling of the sessions in that document is still slightly underspecified.
You mean too sloppy and needs to be tightened up?
I think it's much more closely aligned to doing DNS over TLS than the document implies.
Okay.
And I think given that we have a document that specifies DNS DNS over TLS. I think a little more alignment would help implementers see the commonality between them, because I think rather than just flicking a switch on your UDP implementation, it is actually thinking about sessions, thinking about managing IDs, and there's a whole number of things that need to be taken into account there. So I'd like to see a little more alignment there.
So do you want to achieve that alignment by reordering things so it's got the same order as the TLS document, so it's easier to do a diff and see what the changes are, or a section that kind of summarizes how things are different?
I think if we have one RFC and then it's easy to just see, okay, I've already implemented that, how do I now do this? What's similar and what's different?
Okay.
That might be more useful for implementers.
Okay.
Which leads me on to my second comment, which is, because of the uncertainty around that, I'm wondering where the implementation status stands, because my feeling is I'd like to see an implementation of this before the draft moves forward, because I think there are outstanding questions about how this DTLS message flows will work in practice. So I don't know how that will play into it going to a working group last call if we have no implementations.
So this is separate from the message flows document?
Yes, I'm just talking about just doing, just writing an implementation of DNS over DTLS, because I'd like to see this move forward, but I'd like input from an implementation.
Whatever, I don't care.
So,
We can leave it as an ID for a decade if we don't have any implementations, or we can publish it as an RFC and expect and hope that vendors implement against it. My company doesn't implement much against internet drafts, for example. Other companies don't either. So, yeah, that's the chicken egg problem that we've been stuck with in IETF for 20 years. I understand.
Maybe that's a question for the working group as to what they want to do with the draft if there are no implementations. Yep. Okay. Then I pass that to the chairs, I guess.
Well, let's take Paul's question and then we'll.
So you asked which way to do the comparison. Absolutely, ordering would be really good. I think a section, trying to do it in text in a section, will not actually hit the fact that, especially in the last two drafts of the TLS, we ended up having to add a lot of TCP-ish stuff, which you don't have. So if you follow the same order, saying but UDP and but UDP stuff, I think it would be a lot clearer. I will disagree with Sarah on needing implementations. IETF normally doesn't do that. However, I would hope that no one would be promoting the use of DNS over DTLS if we had no implementations, simply because, quite frankly, we don't have a lot of foo over DTLS anywhere. And when the few cases where we have it, there's usually been a BIS because we discovered funny things of DTLS. So I'm happy to see one, but I don't feel like it should be blocking moving to RFC.
Ted Hardy, I'll just note that the RDC Web Data Channel, which is a foo over DTLS, actually has quite a lot of implementation at this point. And so there is an implementers community. If you'd like to contact them, the RDC Web Working Group mailing list is a fine way to get them involved.
I'm just wondering if there's an opportunity to think about making this experimental, if there's no sight of implementation on the horizon. Just wondering if that's an option, rather than having it
That's up to the working
hang
group,
around
not
in the
me.
working group.
I mean, it's a working group document, so whatever you guys want to do.
Just echo, okay.
But
So
then we need to define experimental criteria.
yeah, that's true, we'll need to. So one of the problems we've been having with some of the documents is getting review. This document has been revised a few times and we've had only a very small number of people providing comments. But the working group showed support for adopting it and showed support for working on it. It's just sort of when the rubber hits the road, getting people to provide comments has been very difficult. So, if you'd like, we can start a working group last call, possibly after rearranging. You'll be okay with rearranging? Yeah. Okay, so after rearranging, we can start a working group last call to try and solicit a bunch more review and feedback. It's a little sad that, we have to do that to get the feedback, but.
No, it should be just a couple of weeks.
Okay,
Yeah, thanks.
Cool. Thanks, Dan.
and now we have Sarah. Oops, wrong view. Would you like the clicky thing?
You clicky thing is all yours.
How long is this for? 50.
Okay, so I'm going to talk today about the authentication and DTLS profiles draft, which covers both DNS over TLS and DNS over DTLS. So starting with a recap of how we ended up here with the drafts that we have at the moment. We have the two drafts that have been going through the working group. DNS over TLS is now approved as an RFC. That will be out any day. And we also have the DNS over DTLS draft that Dan was just talking about. When they originally came out, they both contained descriptions of how to do authentication, and there was some overlap, but there were also some differences between them. As the DNS over TLS draft progressed and went to working group last call, the decision was to retain some description in there of how to do authentication. And what's in that draft today is a description of how to do strict authentication using SPKI pin sets. There's also a discussion of how to do opportunistic security. But there was a discussion in Yokohama about the fact that then left the DTLS draft with its own description of authentication. And what would be much better is to generate a combined draft that applied to both protocols equally. So this draft was born. The authentication sections were removed from the DNS over DTLS draft. And we also incorporated a section from a third draft relating to specifying which DTLS and TLS extensions should be used when doing DNS over those protocols. We produced the first version of this draft in December. It was adopted in January, and we've had one minor revision since. So what's actually in this draft? So as I said, what's in here applies equally to the two protocols. We talk about authentication of recursive DNS servers by clients. We do not cover authentication for clients by recursive servers, and we do not talk about authentication of authoritatives by recursives. All those are deliberately out of scope for this document. We're not saying they might not be needed, we're just saying this isn't the document to deal with them. We also focus very specifically on domain name-based authentication. And when we need to make a reference to using SPKI pin sets, we just normatively reference the DNS over TLS draft. We also introduce a term just to try and describe those servers which are capable of offering a privacy service as a privacy-enabled DNS server. And that's a server that fully implements this draft. So one thing I wanted to run over was some of the terminology we use in this draft, which we had some feedback that this was a little bit unclear and confusing. So I'm hoping to spin over that and then get some feedback. What we do in this draft is we take the approach of describing usage profiles, which are profiles defined just by their security properties, and therefore the security guarantees that they can deliver to the user. And we separate that concept out from which authentication mechanism is actually used to deliver the security. So we talk about three types of security of usage profile. So no privacy, sending stuff clear text, opportunistic security, and strict security. This caused a bit of confusion. The feedback was this caused a bit of confusion because firstly, that separation wasn't as clear as it could be in the current draft. So we're going to address that. And secondly, because when you read this draft alongside the DNS over TLS draft, in the DNS over TLS draft, because it was only one authentication mechanism, it appeared that the usage profile and the mechanism were very tightly coupled, and that was slightly at odds with the description here. So I've worked with Stefan, and we think we've come up with some text which will clarify that situation, and that will go in the next revision. So just to step through the usage profiles and some of the other feedback we've had on what the meaning of these are, I'll start from the bottom up. So we start talking about no privacy, so you're sending stuff clear text, no privacy guarantees. The next one we discuss is opportunistic, and one piece of confusion I've heard from a lot of people is that initially they think that this means requiring encryption but not authentication. And that isn't the case. It's very important that users understand that if they choose to use opportunistic security, they may fall back to clear text, in which case they have no security guarantees. We tried to, in the draft, we created a table where we tried to illustrate the difference between the usage profiles, and that table alone caused a lot of confusion as well. So one thing I'm proposing is that for the next version, we extend it and we break down more clearly what happens in the opportunistic case. So P here is that you have protection, N is that you have no protection, and D means you're able to detect an attack. What we did in the draft was we just had the line involving clear text opportunistic, which is of course the worst case scenario, which is what the user has to assume they might, the state they might end up in. But because the table didn't clarify that enough, I think people were confused. So I hope if we present it in this form, it will resolve that problem. So another piece of feedback we got was that...
Tetrardy, quick question on the previous slide, which I like this presentation a lot. I think it's very, very useful. I also, it also causes me to wonder, however, whether maybe opportunistic is covering a bit too much ground as a general label, and whether we ought to suggest splitting it between the case where you have authentication and encryption falling back to encryption without authentication from the case where encrypted, whether authenticated or not, falls back to clear text. If we were to do that, I think we would actually give a slightly better representation to the folks who are looking at these labels about what the different state or state transitions look like. Unfortunately, I have no good term to suggest. So if anybody does, I think it would be valuable, but I can certainly see that in the absence of something, putting fleen in there is not going to help anybody.
And I have slides later on exactly that point, because the question is, how much granularity do we want to offer? So another concern is that the more granular you make it, the more likely a user is to think they're getting one level of security and end up with another. And we've seen this in practice, because when we've been developing GetDNS, we've been trying to specify in the API how users choose what they want. And the confusion around that has convinced me that's what convinced me to make the separation between the usage profile and the authentication mechanism in the first place. And it also convinced me that less is more, which, so the story, I'm leaning towards the story is, if you care about security, do strict. Don't even think about doing anything else if you really care. Otherwise, opportunistic, you've got to really treat that as clear text, and because ultimately you might end up there. Whether there's value in the intermediate case of wanting encryption but not authentication, we had a lot of back and forth about this, I mean, particularly with DKG, and we landed on no, there wasn't, and it was just potentially added more confusion, but I think there is a discussion to be had there.
Christian Wittmer from Microsoft. Sarah, I read your draft and I'm a little bit confused about the user model. Mm-hmm. The user model I have in mind for DPRIVE is that of doing a VPN to your first recursive resolver. Typically, I mean, you do an encrypted TLS session to your first recursive resolver. And that resolver, in my mind, is typically configured in the client as says, this is the resolver I trust. And that trust encompasses things like, it's not going to lie to me, it's not going to take my data and sell it to advertisers, it's not going to do nasty stuff with the DNS, etc. Now, that means something which is largely configured in the client. Like I want to use, I don't know, VeriSign services because I trust VeriSign for some reason, so I'm going to use them. Okay. And in that case, and that's my main usage scenario, I would not categorize that in terms of strict, opportunistic, or whatever. I would say, I want my DNS traffic to go there. I don't want it to go somewhere else.
That's strict.
That's strict then. It's strict. It's just.
Yeah, but at the same time, when I read your draft, I see a very different model of usage. The different model of usage is, I have a DNS query. Let me pick a server among the available servers, probably from DNS records or something like that. And then try to dynamically establish a TLS connection to that server and decide whether I do that or not. And then my fallback case is not do nothing. My fallback case might be, I have a policy that I send all my traffic to my first hop resolver, or I have a policy that sends some of my traffic to the first hop resolver, and maybe I send some other if it is secure. And the articulation between this dynamic discovery of server and the model in which you have some kind of a subscription to a first hop resolver is not clear in the draft. I don't see it.
So the intention here was to do that the other way around. Maybe that's why it's not coming across. It's to say you choose whether to do strict or not, and then how you choose to do that to what kind of resolver is the secondary consideration. And that might be through a trusted relationship with the SPK pins, or it might be through dynamic discovery. But what you're not wanting to do is say, well, if I can get to that server that I trust, I'll use privacy. But if I can't, I don't care, I'll do anything else. Because that's not strict, that's opportunistic.
But look at the information leak. I mean, if you had some place, the reason we do deprive in the first place is because I don't want the guys in the coffee shop to know which DNS names I'm resolving.
Correct.
If I start having a bunch of TLS connection to a variety of authoritative servers, then it's almost as good as disclosing which DNS names I'm resolving.
But in that situation, you're going to get to one resolver and be able to authenticate it and do strict and carry on, or you're not. You're not going to jump around, or maybe I'm misunderstanding.
It's not clear in the usage. I mean, basically what my suggestion is that there should be a usage model for this document, looking at what is the usage model that you're securing and what are the guarantees. Okay. When I read the document, I have the impression, in the document that the recursive resolver is in the client itself, and that it's trying to do dynamically TLS connections everywhere. Well, Warren, I see you shaking your head, but that's my impression, and you cannot deny that it's my impression. Okay.
No. Sorry, I wasn't intending to do that. I suddenly realized what it is that how you had read that, and I was like, no, I wasn't intending to say no, that's not your impression. It was like, I just figured out how you read that.
Yeah. And so I'd like to see some kind of clarification of the usage model first, before we engage in the fine-grained description of how we could connect that to that resolver.
So I see that. Maybe what we should discuss offline is whether you think that usage model is context-based. You're saying you have one usage model in an enterprise and one in a coffee shop. Whereas I think what we wanted to do in this draft is say you can make a decision that you operate the same way wherever you are, and you just always do strict. And how you get to being strict is different. So, but yeah, I'm happy to talk offline. I think I see where you're going with that.
Ted Lemon, so I heard you saying that there's a fair amount of confusion about what opportunistic means, and you find yourself explaining it a lot.
Yep.
That means that it's broken.
Right.
It doesn't, and my point is not that you need to change what opportunistic means, but rather that opportunistic is actually not a good usage profile. What you actually want is strict or no privacy. Or actually what you really want is strict or there might be privacy, but we make no promises. I don't think you ever want the user to have to decide between opportunistic and no privacy, because the mere act of asking them to make that decision implies that opportunistic gives you privacy, which it doesn't.
Right. We didn't have the no privacy in here to begin with, and we put it in for completeness, just to sort of distinguish it, but maybe that.
Yeah, I think you need to get rid of that, and then opportunistic starts to make more sense.
Okay, okay,
Yeah.
thanks, yeah.
And we're cutting the line after Christian for this particular bit.
Stuart Cheshire, Apple, very quick comment. Listening to the discussion with Christian, it has echoes of things that I hear a lot. I think there's a big confusion because in DNS, we use the term DNS server to mean two different things, the recursive and the authoritative, which I think is just a historical accident because NameD implemented both in the same piece of software. I was understanding this to mean this is my first hop to my recursive. So if I've configured 8.8.8.8 using Google DNS, then I have privacy to that, and I trust Google and everything downstream. If other people are reading it differently, that this is privacy for this hop to the authoritative server, I mean, I see you're shaking your head, and I agree with that. But it seems like there's some miscommunication going on, and some people are not clear on that.
There is a bullet point that specifically says that's out of scope, but maybe it needs to be made more
No, I
prominent.
agree with you, but it seems to be this recurring source of confusion in DNS discussions.
Yeah, that needs to be stressed larger, because, yeah.
Has come up again and again, so thanks.
Christian Wittema from Microsoft again. On the user decision, I mean, there currently is very little user interface to DNS resolution. It's typically done by a call to get host by name or something equivalent in the bowel of some program somewhere. And so I don't see how users will make this. I mean, we have to have a usage model there to say how will user make the decision to say, oh, I want to use it or not, and what is the fallback?
I mean, it's not dissimilar in some ways to DNSSEC in that respect, that, you know, it's not inbuilt into the libraries, it's there, and the users don't often make that explicit decision for things that they do. So I think we have some of the same challenges there, and that's one of the reasons we've been focusing on Get DNS as a way to expose that more up to the application and user level. But I agree that when you get a brand new laptop, you don't immediately have a little checkbox that says, I want all my DNS to be private.
No, am I supposed, for example, to pop up a warning to the user saying, hey, grandma, make a decision. We have an issue there because on this particular coffee shop, I cannot reach your trusted resolver. What should I do? Is that what we want to do?
I mean, that's...
IETF does not make UXCC.
Yeah.
Sure, but I mean, I would have to do that, and I want to understand what's the mechanism there.
So,
I'm Stefan Bartsmeyer. I'm not sure I understood Christian's concern about usage models, but if I understood, I disagree. Because I think there are many, many usage models, a lot, hundreds of them, and it's simply not possible to enumerate them all. So I like the idea of having a few profiles. In the current draft, there are not enough. In this slide, maybe a bit too many, but I like the idea because it could be realistic. Decreasing the number to only 2 strict and no privacy is not realistic because we have a lot of experience with X509 authentication of TLS session with the web, and we know it's too simple. So we need something in between, even if it's, I agree, not easy to describe it. Now for the user interface issue, there are a few user interface points in the draft, such as some warning should be sent to the user, something should be logged, but it's typically not our business because there are many, many possible ways to interact with the user. We don't know all of them. And it seems to me that as a general rule, it's not a good idea to turn us into user interface experts and to try to go on spot. So what we should do is document a few profiles with clear privacy properties, and a table like this one is, in my opinion, the good way to do it. And then it will be up to the software authors to either hardwire a profile or to present a choice in the matter they want to the user.
Yeah, I think the value in being able to report anything to the user is really just for debugging and diagnostic purposes. So I happen to be doing opportunistic. Could I switch to strict if I wanted to? Because I can actually see, I can authenticate this. So we only talk about it in that context, the feedback to the user. I agree.
You're doing okay.
Okay.
You're way over, but that's okay, because we've got,
I try and, some of these we've already touched on then. So one thing that is worth mentioning on this slide is that when we talk about strict, it is a authenticate or fail model with regard to doing your DNS lookups, but we have in the most recent version of the draft qualified that certain meta queries that you need in order to bootstrap your authenticated connection can go opportunistically or in the clear, and they're really, but they must be DNSSEC validated. I have a slide that shows that slightly better down the road. This was just raising the question of should there be a super strict policy where you don't even let the meta queries go encrypted, but we think that just makes deployment just impossible, so we haven't gone there. And this was the question about the intermediate state where you require encryption but not authentication, which sounds like still that's up for discussion. I'll quickly run through these. So this is the authentication mechanism that was in DNS over TLS draft, which is the idea, which is the idea of where you have an out-of-band SPKI, and you, these are the old slides, but never mind, okay. Sorry, there's a couple of mistakes on these, where you have the out-of-band case, and that's that left-hand side where you can do out-of-band SPKI pinning. What we talk about in this draft are these two options here, where you can either directly configure a name, a domain name, get to the IP address through an opportunistic SRV lookup. So the grey lines here are what you directly configure. The orange line is an opportunistic lookup, and the double-headed green line is the TLS handshake, where you actually do the authentication. So the next stage, after you've got to the place where you actually have the IP address and a domain name, is that if you so chose, you could go ahead with your TLS handshake and just authenticate against the name and the certificate you got back. The other option, hey, we're DNS folks, we invented Dane. We should be using Dane for this, right? So what you can do, as long as you are a validating stub, you can go and directly look up the Dane records you need, validate them, and then use them in the TLS handshake to authenticate the server. And it should be the more general case there, if not just an X509 cert, but just the server credentials. There's a third case that we talk about, and this is one of the ones we'd like to promote, which is once you know the domain name of the server, you could choose to use the proposed TLS DNSSEC extension. What that does is actually a TLS extension that's in the TLS layer, and the client can request that the server provide all its Dane records in the client hello, because the server knows who it is, and it should be able to provide the full chain of records to allow a validating stub to fully validate using DNSSEC those Dane records. And when you do that, you can then also in that handshake, you obviously get the server credentials, be that a certificate or the keys, and then that authentication is self-contained within that TLS handshake transaction. One of the reasons we really like this is that if you restrict the Dane to, that should say, if you restrict it to using EE and SPKI, then in principle, you can actually take certificates, CAs, out of the chain entirely, and you can go through this mechanism, and the only piece of information you leak is which server you're connecting to. And I know there's more thoughts about this going on in the audience, so, but this seems like the way we would like to do it if we had all the pieces in place. I skip over that because that's already a question in the draft. Very briefly to say that we know that there are thoughts around TLS 1.3 and how that interacts, and there is a section in this draft where we could potentially expand on the usage of TLS 1.3 depending on competing timelines. Very last quick word on implementation, as I've mentioned. GetDNS does quite a chunk of the specified authentication. In terms of servers and bounds, we all know that's done TLS for a while, but I wanted to quickly mention some great work that was done at the hackathon over the weekend, which is that the not resolver, as of Sunday evening, can now also act as a DNS privacy enabling server. So we've got TLS in the not resolver that's coming out, which I think is great news. Great, that's everything. Thank you very much. Any more questions?
Two quick ones that are related. The first was that you had put, you had said that authentication by domain name only is in scope. I think that's a big mistake, given that current DHCP gives you out an address for your server. And related to that, the question of should we, go here? Yes, please do.
But so the issue we face here is that this requires you having a trusted and secure connection to your DHCP server, which you go to a coffee shop and you don't have. So.
Right, but in your home you might. So saying that this is only for coffee shops, I think is way too limited.
And there's also, but my understanding is there's also issues with secure connections over IPv6.
Right. So, but I think it is worthwhile doing this also if you're in a coffee shop that happens to have a DHCP. The response from DHCP is go to 8888, and they're willing, and they have a certificate for 8888. We should be able to use it.
Who has the certificate? Sorry.
That if Google gets a cert for 888 with the authenticator being IP address equals 8888, which would make sense because no one knows that it's called. In fact, I don't remember the name of it. So I believe we should actually have it.
So my feeling is I can see this happening in the future. I'm reluctant to include it in the draft and have it potentially block.
Why would it block?
Getting the code point for.
Oh, I don't think it has to block to get the code point first. I think we just need to allow this to happen. I think you can say a future DHCP extension might be this, and that would be a completely separate draft. It doesn't have to block at all.
Okay.
Christian Wittmer, Microsoft. The DHCP option is one potential response to a problem that is not discussed yet in the draft, but should be, in my opinion, which is what happens if you're on an enterprise network in which when you are in the enterprise network, you really want to use the enterprise server because otherwise you are not conforming to the enterprise policy, you don't get their dual-faced DNS and all that. Versus when you are in the coffee shop, you want to use your preferred resolver. And basically, how do you make that switch to do one or the other is kind of part of the policy that we have to have in these clients. And there has to be, at a minimum, there has to be a mechanism to say how you do it.
You see that as something we should specify in this standard?
Okay.
Well, at least we should describe the problem.
Yeah, I mean, it feels like a policy decision that we might elaborate in the discussion, but I don't feel we should be dictating how that gets done in this document. It's my personal feeling.
It's a question of configuration more than a question of authentication. If your draft only covers how to authenticate that I am indeed using the server that I have programmed, then no, the answer to the question is no. If the purpose of the draft is to look at management options for DNS or TLS, then that is definitely in scope, and we have to look at that.
So my understanding of the scope of this document was that it was the former, not the latter. It was a simpler case. It's just how do you do the authentication, not the bigger context question. But
I believe you're correct. I believe. But
So,
that's
so
what I
the
was
question for
missing
the
there.
chair is then where will we discuss the bigger context question? I could do that. But
possibly another document. It sounds as though you have some strong thoughts on it. Would you be willing to provide a document which discusses?
I can definitely do a document on this particular configuration issue. It's to the point that there are certain advisories about these issues. So it's,
Yes.
it's
Yeah.
real.
And yeah, I think it's important to discuss. I don't think that this is necessarily the right document to do it, although it might have some feedback for this. Yeah.
Stefan Bartmeyer. Regarding the authentication by IP address, I have a question for the people who know about the certificate authorities. Is it possible for the typical CA to get a cert for an IP address, and how do they check that? I'm interested, because otherwise it means that the option would be useless because it would work only if there is a pre-configured CA in the client, this sort of thing.
It's a really good question. If I can.
Actually, that's what I was coming up to talk about. The answer is yes, you could. No, you can't. Because I'd have to check, but I'm pretty sure that this is one of the things that was taken out in the BRs.
Yeah.
Now, if IETF asked and said, we really want to have those IP addresses in, I'm pretty sure that CAB4, but I don't think that you want to. I think that every internet service, including private DNS, should be accessed from a domain name. And okay, you might need to go to an unprivate DNS to bootstrap, but we got to get rid of those silly numbers. The IP, particularly when you go to IPv6.
Yeah.
If you want your users to be typing in the IPv6 DNS addresses, you
lose. Yeah. And for those not in the room, that was Phil Hombaker.
So this is DKG. I want to agree with Phil there that if what we're talking about here is helping people get to the strict authentication case, they need to be authenticating to a server that they know what it is. And while maybe everybody in this room knows that 8.8.8.8 is Google, I doubt that there's any other IP address that everyone in this room knows. And it does. I mean, yes, everybody knows some IP addresses, but they don't necessarily know who they are. And the point of this, the goal of this draft is to describe how you connect to the service that you think you're connecting to. And IP addresses are not the way to specify that for normal humans or for configuration that people can remember.
And just related to that, if we're not doing the whole DHCP thing now, but it is relatively easy to get a new DHCP option added. It's not too difficult. We could go down that path separately.
Right. I'm not DKG, but I largely agree with DKG. So first, it doesn't really matter what the BR say. Not DKG. It doesn't really matter what the browsers, what the BR say, because browsers have no interest whatsoever in accepting IP address certificates. And so, some other CA could of course stand up and IP address CA, but why wouldn't one want to? I have no idea. It seems to me that there are exactly two scenarios. One scenario is the scenario where you have a human entered channel, as DKG said, that contains a human entered name, which then somehow has to be mapped in some other way to a piece of key material. And naturally that should be done by mapping domain names to certificates in the classic way, whether it's via PKI or DNSSEC. And then in other situations, we have a machine entered doodad that came from somewhere else. And while it might seem attractive to say, well, we're gonna have an IP address and then we'll have some lookup procedure to find the appropriate piece of key material, because you don't want to screw with whatever thing doodad delivered that information, so that that's actually not going to work out very well, and you'd be better off either delivering the domain name via that scheme or delivering the pair of an address and a piece of key material to look at. While that may seem inconvenient at the present moment, you will find it more convenient later.
Phil Hambaker again. Could I just remind people that recently when we had the issue in Turkey and people were painting 8.8.8 everywhere because the DNS was filtering out YouTube and all sorts of other stuff because the president didn't like being told he was a crook. The problem there was it was very fragile. And what we saw in our public DNS service was suddenly in the middle of the day, the traffic just quintupled in the space of an hour. And that was when they started blocking 8.8.8. And so I think the moral here is that we don't want to rely on numbers. We want to have labels. And also I would like to have the paradigm be, this is something, you only need to do this binding once per machine. This doesn't need to be, I open up my laptop every time and I acquire the DNS address of the server every time. Those servers should not be moving around, resolvers should not be moving around at a great rate of knots. So this is something where you should be able to do a binding and it be good for a year or more, unless it gets blocked.
Yeah. Yeah, I mean, we're potentially going down a huge DHCP type rat hole, but in some places, you first need to use the local coffee shop's untrusted, unsecured resolver so you can do the whole captive portal-y thing. But then once you've managed to reach, the internet, whatever that's defined as, then you can. Okay. So do you have any questions that you need answers to from the group? Great. Okay. Thank you. I believe that was everything major on the agenda. I wanted to mention something. I've got a couple of questions from people before the meeting. Oh, are we doing the? Okay. So let me quickly do my thing, and then we'll have DKG do a quick update on, potential of this and TLS 1.3. So I've got a few questions from people on what's with this Google DNS over HTTPS thing. That's not intended to compete with this at all. It's in no way intended to be used, for a system resolver or anything. That was if I've got a web app and I want to make some DNS call, or my piece of JavaScript would like to be able to look up a name, it's designed for something like that. When I mentioned to the developers, people might try and use it for this, there was a sort of deer in the headlights look and, oh my God, no. So, just to calm people down, it's not intended to be a replacement for Deprive or to compete with Deprive or to be used for anything like Deprive. Okay, that's my little disclaimer out of the way. And we have 15 minutes for DKG. I don't think you had any slides, correct? That's perfectly.
Okay. We called on you yesterday, so.
Hi, I'm Daniel Kahn-Gilmore. I wanted to talk a little bit about the relationship between the DNS over TLS work and the upcoming TLS 1.3, with a particular focus on the zero round trip mode of TLS 1.3. So folks were asking about what are the potential advantages and what are the potential risks of using the zero round trip mode. So I don't know how much people have been following the zero round trip discussion. It turns out, so the goal of the zero round trip mode for TLS 1.3 is that you should be able to, if you've already made a connection to a server in the past, you ought to be able to make your next connection with data on the first flow. So the client can send data on the first flow, because that makes things nice and fast, and everybody likes fast. The concern turns out that zero RTT data has a number of subtle security differences from what we expect from standard TLS connections. And so I'm going to enumerate what those differences are for the zero round trip mode, or what I think they are, and hopefully other people who are thinking about these questions can correct me if I've missed anything. And then I want to talk about how that might relate to the stub to recursive resolver that we're working on in this working group. So if people have questions, please just come up to the mic. So as far as I can see it, there are at least 4 security properties that are different about data that runs in the zero RTT in that first flight of the zero RTT. So those 4 differences are, I'm going to pull my crib sheet here, sorry. The 4 differences are, one is that we don't believe you can do client authentication in a sane or safe way in zero RTT. That is TLS-based client authentication. The next one is that the forward secrecy guarantees are different and less. The third is that there is no replay protection that we can make a good argument about. And the fourth is that there is additional client linkability. So I can talk about each of those and how they relate to DNS. Yeah?
I didn't realize you were going to expand on those, so maybe I'll just...
Yeah, I'm going to expand on them.
Because I would nitpick several of those.
Yeah, no, we can nitpick. So first off, for the client authentication, I really don't care. I don't think that's relevant for us in the DNS case, so don't worry about that. The client authentication, I don't think that's relevant. DNS has never traditionally been client authenticated, and we're not going to make it client authenticated for this case. The limited forward secrecy concerns, I actually don't think are much of a concern. The forward secrecy that is provided, sorry, Shane?
Hi, Shane Kerr. So just to be clear, you're talking about client isn't able to present a certificate to the server then?
In the zero RTT case. This doesn't mean that client authentication is not possible. If you wanted to do client authentication, you could do it in a 1 RTT or 2 RTT case, but you wouldn't be able to do client authentication in that first flight. So, but by the way, 0 RTT is effectively session resumption, which means that if you believe that your semantics of client authentication carry across a resumed session, and this is a semantic question, not a question of protocol design, then you could do a 1 RTT or 2 RTT handshake that includes client authentication, that establishes a session, and then you could resume that session and your server could say, oh, well, I know who that is. So the client authentication could carry across, but you're not going to do client authentication on the 0 RTT handshake.
Okay, then I think your assertion that it's not so important makes sense. My concern was that there may be business models where people insist on this authentication.
Indeed, there may. Right. But the answer is don't do it in 0 RTT. So, so for the forward secrecy concerns, the forward secrecy is different because you're not doing a Diffie-Hellman handshake over that particular data. But it turns out that the forward secrecy concerns are no different than normal session resumption forward secrecy concerns. They tend to be constrained by whatever the state is being kept on the server, which is different from the long-term secret key for the server. So I actually don't think the forward secrecy concerns are an issue for DNS either.
Yeah, I mean, I would agree with that. I guess I would say two things. One is that the forward secrecy concerns of 1.3 are strictly better than those of ordinary resumption in 1.2.
Yep.
And that unlike in many DNS configurations, because you actually you're actually running one server as opposed to 50, or you have some sort of locality of reference. You could run a stateful resumption scheme and use the kind of PFS style things Bill Haas has been talking about on the mailing list. So you have a number of opportunities to do a better job here than you ordinarily would.
Yes, I think that's right. So those two security concerns I think are not such a big issue for the stub to recursive. So let me get into the ones that are a little bit more problematic. And those are the replay protection issues and the client linkability issues. So let me talk about.
You got about 5 minutes.
Sorry. Yeah. So replay protection. We don't believe we have a story for how to defend against a replay attack of 0 RTT data. For DNS privacy, one of the concerns is a network attacker who sits and observes the resolver and sees what queries that resolver makes to authoritative servers as a result of an incoming query. So even though the stub to recursive is encrypted, you can observe the traffic on the resolver and see what it does. There's a case where the resolver actually contains all the information in the cache and doesn't have to make any queries, and an observer can't tell. But because 0 RTT is replayable, it's conceivable that someone could a network attacker who can monitor the recursive resolver could replay the query that came in over 0 RTT at different times and wait for the cache to expire and see what kind of outbound queries they could discover. So the replayability, I think, does present a potential concern for the confidentiality of DNS queries sent in the 0 RTT flight.
Ted Hardy, there does seem to be a configuration mechanism for mitigating this attack, and that's specifically that the resolver should allow a particular session resumption ticket to be used for a particular period of time or for a particular number of cases. And in the case where it refuses 0 RTT after the session resumption ticket has been overused, this actually goes down, if I understand this correctly.
That configuration makes sense as long as your server is capable of storing that kind of state of how many times has a session ticket been used.
Yeah.
But in a anycasted situation, we don't have any guarantees that that's necessarily going to happen. So for example, in an anycasted situation where you've got multiple data centers answering to the same name, and I get a 0 RTT flight to one of them with a session ticket, I could play that to the other one that doesn't have the same cache and see what its responses are.
That's true, but as I said before, if you do it for a particular case or limited period of time, in addition to number of uses of the ticket, the period of time is something that is associated with the ticket itself, right? Because there's a timestamp.
Right, you could store a timestamp inside the ticket and then limit the replayability, and hopefully that would be smaller than the TTL or something like that. So there are some mitigation strategies.
Yeah, no, I'm not saying that this isn't an issue. I'm saying that there are configuration mechanisms that would limit or mitigate this. And I believe that in the case where you're talking about Anycast, it's also entirely possible that you might have a situation where your zero RTT resumption was actually only valid for the Anycast resolver you first talked to. Because otherwise there's a key sharing problem across your Anycast servers, which will not occur if they're actually in different autonomous systems and run by different things, which is a common case for certain parts of the DNS hierarchy.
Yeah, so I see a big line forming, but I really want to mention the client linkability issues though, because I think that's
I want to make one correction to what you just said earlier, which was, I believe that it's only the first query that is replayable.
It's all queries in the zero RTT flight.
I'm sorry, okay, which would be, if we're doing single query, would only be one query. You had said earlier the queries. I just want to make sure that people understand it's only the first thing that you said.
It's not, it's all of the queries in the zero RTT flight, which means you could send a bunch of stuff, you could keep sending a bunch of stuff, and until you've gotten the second part of the TLS connection back and done the additional key transitions.
And
so the client linkability is a concern that I wanted to raise here. So if you're doing a bunch of queries over a single TLS session, then clearly the DNS recursor can tell that you are the same client because you're using the same TLS session. So that linkability already exists. It exists for DNS over TCP as well. They can also distinguish you between other people using your same IP address. But as soon as you start resuming, and zero RTT is in essence a resumption, then the recursor can tell that you're the same person who made the last session of requests. So that means that if I resume, if I'm on network A and I tear down my connection, I move to network B and I spin up the connection and I resume using zero RTT, now the recursive resolver can identify me as the same party that was in both cases. This is the inverse problem of the no client authentication, right? Which is that you have inadvertent client authentication. In TLS 1.2 and all previous versions of TLS, this is true not just for the recursive resolver, but for any network observer. The network observer can monitor the TLS session IDs that are granted by the server and sent back by the client on the subsequent connections and tie those sessions together. So there's an issue that your DNS queries can be used as a mechanism to track you across the network if you continue to do session resumption. So I think it's important that if we're talking about DNS privacy, that we say clearly that when you move sessions, when you move network connections, you should avoid session resumption. And that inherently means avoiding zero RTT.
And I'm inserting myself in the queue quickly. OpenPGP starts in like 3 minutes in the same room. So we could probably continue this outside.
I'm also chairing OpenPGP.
Well, okay, well, there we go then.
I will continue outside.
We'll just swap over to Vail at some point.
I'm okay with this going a little bit longer
Excellent.
because there is a queue here.
Me too.
We don't have I don't think we'll use the full time.
Excellent.
So, Stephen, so I think this is kind of really good kind of analysis to do, and I'm delighted to see it. And I hope other foo over TLS protocols do the same kind of thing just as well. So that's really good. So let's imagine the outcome here was something like, you don't need replayable zero RTT data between stub and recursive, but maybe you want it between recursive and authoritative. So let's just imagine that might be an outcome. I have no clue as to how feasible it would be to implement and deploy that in DNS servers. Can I turn on that kind of distinction usefully? I just don't know. So I think that would be.
Yes, I think they could.
Right. All I'm saying is I think that aspect would be a fine additional part of the analysis that you did.
Yeah. So I also wanted to be clear that the client has the option, in terms of client linkability, there is a way to construct a TLS client profile that avoids, for TLS 1.3, when the server gives a session ticket, they give the session ticket under encryption. So a network observer can't observe the session ID when it goes from the server to the client. However, when the client resumes a session, the network observer can see the session ID. And so if you have a TLS client that is configured to only resume a given session ID once, then with a given session ticket once, then the client will not be linkable by network observers, although they will be linkable by the resolver. Okay. So it's important, I think, if we're thinking about this from a privacy perspective, to ensure that DNS clients, and this is zero RTT or even non-zero RTT if resumption is the case, that we say that TLS clients that are privacy sensitive only resume a given session once.
Christian Witema, Microsoft. Daniel, I really think that what you're describing is a problem with TLS in general.
I agree.
And that the proper way to address that is to have a discussion of TLS-related privacy issues in the TLS working group.
Yes, and we're having that there, and I'm planning on sending a pull request.
It's kind of embryonic in the TLS working group, but maybe we should work on it there.
Okay, I'm happy to do that. But I think as a DNS community, we can say when you are doing DNS privacy as a client, you must use this kind of profile of DNS client behavior. Like, do not reuse a single session ticket.
Well, yeah, sure. I mean, if you don't understand what you're doing, don't do it, please.
Unfortunately, we are all doing stuff we don't understand.
Ted Hardy, I just wanted to pull out something you said and make sure I understood it correctly, because I think it actually makes one of the problems I thought you were raising far more tractable. And that is this: if I get the session resumption ticket on, let's say, my wired network, or let's say a Wi-Fi network, and I lose connection to the server because I have now transitioned to a cellular network, if I use that session ticket on the cellular network for the first time, that is, I never did a session resumption on the Wi-Fi network, it is in fact safe to do so. It is linkable to the recursor, but not to the observer. Is
That's
that correct?
Okay. On TLS 1.3.
In TLS 1.3.
On 1.2 and earlier.
Right. But what that implies to me is that the situation that I thought you were saying before, never reuse these on different networks, is in fact, or never use this on a new network, is in fact never reuse one you have already used on a new network. And that's far more tractable, because one of the problems we're dealing with here is the correct answer on different networks that you would get from recursive resolver may change, right? Because its geolocation of you has changed or some other answer has changed. If it is possible to use it on a new network, provided it is for the first time, it's a far more tractable problem from the DNS perspective, in my opinion. So I think it's important to call out that difference.
So I think we need to keep the linkability question in mind, both for the network observer, which is quite bad, in which case your thing addresses it, but also for the resolver. If I'm talking to a public DNS resolver, I don't necessarily want them to know that the set of queries coming from this IP address at time t+1 is coming from the same client that had this other set of queries at time t.
So I think that's worth writing down, and you'd say, hey, if you don't want this, don't use session resumption, and being quite clear about it. But I think that the linkability to a network observer is actually the problem this group is most focused on trying to solve.
Okay.
So, I mean, you mentioned this point earlier, but I wanted to sharpen it a tiny bit, which is that 1.2 does not have this property. In 1.2, to the best of my knowledge, there's no way to do resumption, to multiple resumptions that does not involve creating network visible linkages between the connections.
I agree with that.
And so as I understand it in 1.2, you know, if you wish to have multiple connections that are unlinkable, you must initiate completely new handshakes every single time.
That's correct. There is no, in 1.2, there is no way to do unlinkable connections and resumption at the same time.
Okay, so that's something that definitely should be called out somewhere.
I'm calling it out right now.
Huh?
Yes.
Yeah, very sharp way, right? I mean, because the only reason I'm mentioning is because it means that that's a case where the very, very different properties between these two protocols, and you wouldn't want to do something you thought was safe on 1.3 and then have it be disastrously crappy in 1.2.
Right.
Alison Mankin, I wondered if we should have some text, the DNS over TLS documents in the RFC editor. Do you think, AD, you would like to put a little black box or something like that?
Terry Manderson, AD. I don't really want to see this text in those documents. I would like to see a document on its own merit that addresses this for DPRIVE.
Okay.
Okay.
Thanks.
Yeah. So sorry, I wasn't following the conversation because I think there are. I don't think Eka's quite right. There are ways that you can do it if you allow either server state and have a counter in the protocol, or alternatively, you have some sort of time-based ratchet, because you're talking about the cache staleness issue. So if you had a mechanism that guaranteed that when you're making the request, if the request is sufficiently out of time, that you know that your resumption token.
I think we're talking about brainstorming TLS resumption patterns right now, which maybe we should do somewhere else.
Yeah.
I mean, I'm happy to do that with you. I think it's important that we do it, but maybe this isn't the wrong place to do it. It might not be DNS specific.
It is a problem that I considered at length in my protocol, and this is the reason I didn't use TLS.
Okay. Okay, so if there are no more questions, I just wanted to put those concerns out there so that people are thinking about them. And it's, these are just issues to think about for DNS over TLS.
Yeah.
Thank you.
Yeah,
that was really useful. Great.
Great. I think we're
I
good.
believe we're all done.
I think we're done. Everybody signed the blue sheets? That's here for DPRIVE.
And thank you, everyone, and a special thanks to our scribes and Jabber people.
That was okay. That was good. That was a perfectly fine and rational discussion. So happy. I did a less than brilliant job with